Good afternoon, everyone. It's exactly 4 o'clock, 4 p.m., so we'll get started. Cost savings with Azure Virtual Machine. That's the session we're going to talk about today. If you are here, we are assuming that you're interested to save some money with running virtual machines on Azure. This is a topic top of mind of a lot of customers that we talk to. Obviously, if you're running large or medium or even small infrastructure, cost is an important aspect. Whether you're running on-prem, especially on the cloud, it becomes even more important. So you are in the right place, and thank you all for joining this afternoon. I know it's getting late with a lot of activities happening, a lot of sessions. I commend you guys for being here at this late, 4 o'clock until 5:15. We've got a lot to cover. So let's get started with the session. So first of all, there's 3 of us. Fortunately, we only have 2 microphones, so you got to bear with us. We're going to be switching the microphones during the session. My name is Khalid Moose. I am Microsoft Program Manager on the Azure Compute team. I've been with the Azure Compute team for just about 4 years. Microsoft about 10 years. You can feel free to contact me at the Twitter handle that I have there on the screen, and I'm joined by...
Yes, and I'm Megan McCrory. I'm also a program manager on the Microsoft Compute team, and I've been in the team for about 3 years now, working on compute billing and VM sizes, and very happy that you are all here.
We're also joined by Rick Halihan from the Cloudera Incorporation. They have a booth, I think it's 2113. The reason Cloudera is here, they've been very open with us, and they want to show us how we're going to use kind of the cost stuff we're going to talk about. They're going to help us bring it together in a real-life example of running a Hadoop workload on Azure Virtual Machine. And it's a very complex application. Rick will go into the details into that and show some of the kind of the best practices, some of the tools we're going to talk about, kind of more like bringing it together in a real-life scenario. So Megan and I, we've been thinking of how we organize the session. By the way, just FYI, Megan just told me this is her first time doing an Ignite session. So please be easy on her while she's presenting the content. But when we were planning the session, we were thinking how there's a lot of stuff to cover on cost. So we try to find a way to organize it, and the way we kind of decided to put it together is there is some planning we're going to go over just to kind of describe, what do you pay for, what kind of cost is involved when you're virtual machines on Azure, stuff like that. Then we talk about automation. It's very important to automate. So we talk about what tooling and stuff like that is provided in the infrastructure to help you automate. Then we'll talk about if you have licenses that you already have from on-prem, how you bring them on Azure, and we'll talk about some options there in different type of workload and licenses. Then we'll describe monitoring capabilities and tooling. We'll demo a few of those. And then, as I mentioned earlier, we invite Rick to the stage, and he will walk us through a Cloudera Hadoop cluster implementation. So planning, the idea is before you deploy stuff into the infrastructure, or if you have stuff that you're trying to expand or maybe redesign and so on, it's very important to plan in many aspects. Of course, for costing, it's even more critical to plan ahead to avoid any surprises. And planning is involved in many, many other aspects. If you're doing like a DR or some type of disaster recovery, backups and stuff like that, you want to plan the infrastructure so you kind of know what to expect. And costing is the same way. So the first step in planning is just understanding what do you pay for when you run a virtual machine on Azure. And to run a virtual machine, you don't only pay for the cost of the virtual machine. There is a lot of other costs that get involved as part of that. First, you may be running some OS. So it's not only the infrastructure that Azure is going to charge you for, but you may be running Windows or some premium Linux where you have to pay the cost of the operating system license. You may be running some additional software on top of that. You may be running like a SQL Server or some other third-party software, maybe like a SharePoint, something else. So you need to account for the licenses and the extra cost involved with the third-party software running on top of that. You may have, obviously, an OS disk attached, which is backed by storage. So you'll have to consider the cost of that. In addition to that, you may have additional data disks. Could be one or multiple. So you have to account for the additional cost for the disk that you're running. Now, this virtual machine is probably not running in vacuum. It's probably connected to a bunch of other virtual machines that you have in your infrastructure. So you have to account for any data transfer between those virtual machines. You may even be running some other cloud services as part of your multi-tier application. And of course, you need to account for all the transaction costs and any IPs that you may have allocated in that virtual machine. And we're going to break it down for you as we move on through the session. Now, there are many factors that affect running virtual machines on Azure. One factor is just the state. Is the VM running? Is it stopped? Or is it stopped deallocated? When the VM is running, it is being charged for all the costs I just mentioned in the previous slide. So the cost of the OS, the third-party software, the storage, networking, et cetera. And this diagram just shows you all those resources being allocated, those lines. But as you move the VM to a stopped state, let's say you go log in, to the VM through SSH if it's a Linux or remote desktop, and then you shut down the VM, then it's in this state called stopped states. Now, in stopped states, the OS is not running, and the additional software within that VM is not running. So you don't pay for those additional costs. However, not everything is deallocated. You still got storage, you still got network, and the VM is still being allocated from a compute side. It has not been released. So you are being charged for the additional infrastructure cost in this scenario. A lot of people we've seen in the past, they shut down the VM and leave, and they come back a few days later, and they say, why is this cost still there? Well, the reason because the VM has not been deallocated or totally been deleted. To do that, you need to deallocate the VM, and the way you do it is through the control plane, where you go through the portal, for example, or through the client tools, and specifically say, I want to deallocate this VM. So in that case, all the network resources has been deallocated. All the, the VM has been deallocated from the fabric controller, so those resources has been cleaned up. However, if you do have storage disks that you want to continue to use, obviously, because you persist in data, you probably want to keep those data around. In that case, obviously, the storage you still have to be, you will be charged for, because if you have data disk. But the OS disk, if you cleaned it up and everything, it will be deleted. So just note, when you go and shut down the VM from within the VM, make sure that that it's stopped state and you're still being charged for the resources that are being allocated. But if you do want to clean it up, make sure you do stop deallocate. In the portal, if you do stopped, it does mean stop deallocated, because I think in the past it used to do stop only, and people were surprised about the price. So that's been changed in the past to make sure that it's been cleaned up. Another factor that affects running Azure VMs is obviously which regions. So Azure has about 42 announced regions so far. We have, I think, 3 national clouds or sovereign clouds. US Gov is one of them, Germany, and China. Those 3 clouds are different environments. They go by different rules. For example, the Germany cloud has data trust model where data cannot leave the country, and also it's being operated by a local operator. I think it's T Systems. China is also similar. It's got operations is by a local operator within the country. US Gov also has, for obvious reasons, security reasons and so on, its own operation compliance stuff that needs to happen. You can see all the regions. These are all the public regions. We also have some newer regions that have been announced, but they are not live yet, such as, I think, France, South Africa, and a couple other ones. Just note that Azure regions also are divided into what we call zones. So when you're looking at traffic costs especially, it is being charged by zone, so it is important to understand all the zones. So here, just kind of trying to put the schema and diagrams to show you the various zones, 1, 2, 3 in the public, commercial Azure, and then all the national clouds and sovereign clouds. So when it comes to cost, you want to make sure that when you pick a particular VM SKU, for example, that you look for the regions, because the price is geo-specific. Typically, you will see that East US 2 and East US and West US 2 are some of the cheaper regions currently. That might change, so you have to check the latest pricing and to know for sure how you're being charged for the infrastructure. Data transfer pricing also is zone dependent, as I mentioned. So when you look at the price calculator, make sure you identify the regions where you're going to be deploying, so you know for the specific cost that you're interested in. Since I mentioned zones, and we've recently announced what we call availability zones, I want to make sure that nobody's confused about those two terms, because they both have the name zones. Availability zones is a different concept. These are what we call locations, isolated locations within a particular region. Just got launched, I think, last Friday or last Thursday, late last week. And it's in 2 regions right now, East US 2 and West Europe, with the expectation that more regions will be coming. The idea of availability zones, these are physically separated locations within a particular region. They are for fault tolerance when you build in applications that needs to be ready for disaster recovery. So you can separate the primaries and secondaries. So if a particular zone goes down for whatever reason, then the other zone or your applications in the other zone are not impacted by the other zone downtime. Each zone has dependent power, network, and cooling, and the reason is because of the isolation. So we want to make sure if one zone goes down, it does not impact the other zone. Up to this point, we did not have this kind of isolation, or if you want to do that isolation before the availability zones availability, you could do it through the availability, what we call the availability sets, where you can deploy multiple VMs into multiple availability sets. In that case, you'll have different and separate fault domains. That's the mechanism we had up to this point. With zones being available, now you'll have even more options to deploy DR type applications that are ready for disaster recovery. Each AZ has one or multiple DCs within it. Intra, currently, because this is preview, both intra and inter-AZ traffic is currently free. We are in preview, so if you want to deploy, go ahead. There is already announcements with the links to how to join preview and so on. But for now, there is no cost involved, but check back as we go to GA. Things can change, so you want to make sure that when you deploy 2 zones, you understand the charges per zone, and there will be calculator updates and documentation that will explain more details. So let's dig in quickly into networking cost and storage cost. In this session, we're not going to go too deep into the networking and storage. We're going to focus more on the VM aspects of it. But we just want to give you some, some of the typical stuff you will hit with running Azure Virtual Machines, and some of the kind of the networking aspects you have to worry about. First of all, data transfer. Obviously, if you're sending data back and forth, there will be charges on data transfer. However, inbound data transfer to Azure regions is free. Outbound data traffic or data transfer is not free. However, it is free if it is within a single region. So when you do design your application, make sure you account for this, because this could play a big role in the overall architecture. For example, you don't want to put compute VMs in one side of the world and data in another place, and then you have traffic going back and forth every minute, and you're being charged, so that your cost can go up really drastically. So when you design these applications, you want to make sure that you collocate data and compute as much as you can. Now, it just depends on your application framework and architecture. It's not always feasible, but you just be acknowledged of this, because it will play a big role on your overall cost of the infrastructure. You will also pay for IPs, whether they are dynamic or static. I believe we provide 5 IPs for free. But there is a little cost, not much, but you'll have to look at the cost structure to account for IP cost for your infrastructure. And you can go to the Azure calculator. I think I got a snippet there, so you can see kind of the cost. Cost can change, so make sure you check the latest. And in your bill, it will show something like this. So when you look at the bill statements and you filter by networking, you will see both in and egress and ingress. Although the inbound traffic is free, it will still show up in your bill. So you'll see how much you're actually consuming, but it will show $0 for the meter. And then if you zoom in, that's kind of what you'll see, and you'll see the regions where you deploy to or the specific zones. Storage. So for Azure VMs, we have what we call managed disk and unmanaged disks. Unmanaged disk is what the model we had up to like about 6 to 9 months ago when we launched in GA the managed disks, where it's easier to kind of manage your disk attached to the VM. Managed disks, in terms of cost, they are charged for the provisioned storage and not the allocated or used storage. So make sure that you account for that in your costing breakdown and estimation. We also support in storage backend both standard and premium storage. And the difference between premium and standard is typically the total IOPS that you get per disk, and also the throughputs. So the cost breakdown is different, but also the SLAs and the IOPS and the throughput SLAs are different. Also, for storage, make sure you look up the data redundancy options. We've got the local data redundancy, we've got the global, and then we've got the read-only access global redundancy. So make sure you pick the right one, and there is different cost breakdown for each of those. Also, obviously, storage capacity. We've got different SKUs, so you might want to check the SKUs depending on how much of disk space you're going to need for your implementation. Always start, if you can, with smaller disks, because we have the ability to resize these disks. So it's okay to start small, and then as you need more, you can always go up and increase. You don't want to put a lot initially, and then you realize you're paying too much, and you want to scale down. It's easier if you go the other way. And then you can always add more disks to your infrastructure as needed. So we've been thinking about, since this session is really about cost, we put like a hypothetical scenario with the line of business application with a bunch of kind of web apps, VMs, and then a bunch of backend worker roles that are going to be doing a bunch of processing. And then some SQL database that will kind of persist the data and so on. So we did some breakdown, just kind of, this is not like probably the largest application, but it's kind of mid-sized application. And then we look at the total cost. If I consider everything without much optimization, if I just go and picked some, let's say 10 nodes of web apps, 8 cores each, and 15 worker roles doing the kind of the backend processing with 16 core each and a couple of SQL Server VMs, and I'm not including all the other services I might have. I might have like a queue, I may have some event hub and some other stuff. This is just purely just kind of an IaaS, VMs, cost. I may have a couple of snapshots for the disks, and did some estimation on like bandwidth if I do like 2 terabytes a day, and then a couple of IPs that may have to be exposed externally. So if I do a breakdown of the cost, came up to, this is annual, not monthly. So it's annual about, $500,000, $600,000. As we're going through the session, we look some of these, automation tools and some of the ideas. We want to see how this cost can change over time, and then we'll see how it goes. Compute cost. So I'll switch it to Megan. She's going to walk us through more details on the actual compute cost I kind of touched on, and we'll talk about the VM SKUs in more details. Megan?
Thanks, Khalid. So up here on the screen, we actually have a version of our compute calculator where you can actually go into the Azure portal and you can basically input what you think you're going to deploy, and it gives you an estimated cost. And so we've already kind of talked about regions, we've talked about software a little bit, which we'll go into more detail, but one of the biggest things that impact costs are the VM size that you choose. Basically, as you know, Azure has a lot of VM size families. So what I've actually done here on this slide is I have the cost per virtual CPU, and so basically I've normalized everything to where if you one core size, here's the price for a given size family. So you can see that some of our newer generations of hardware, like the B series, which we just launched, the AV2, DV3, those are priced pretty on the lower end. However, we have the higher end of the spectrum is our kind of our older generation of hardware, like the D series. We also have the DV2 size, which is the DV2 high memory. That's what that M stands for. So it's the D11 through D15. And so we also have the EV3. So those are kind of on the higher end of the spectrum just because of the memory associated with those costs of the VM. But it's kind of interesting to see this picture. I've also broken it out to the specialized compute as well. So this top line is the general, the second is the specialized. While specialized cost does matter, it's not as relevant just because if you're going to use a specialized SKU, it's probably for some purpose. Like if you're using GPUs, you're gonna look at the N series. If you're trying to run SAP HANA, you'll most likely look at the M. And so I still have it on here, but most people are gonna choose the specialized SKUs for a specific reason, not as cost effective. But that top line really gives you that flexibility between, for my given workload, if I want to run on just a general compute SKU, here's kind of the breakdown. What's interesting though is if you actually look at this from an ACU perspective. And so what ACUs are is the Azure Compute Unit, and this actually allows us to compare VM sizes more apples to apples. And so for instance, we have a lot of generations of hardware. We have the D1s, the DV2s, the DV3s, which all run on different generations of hardware, but that impacts the compute performance of that given VM size. And so actually, if you look at this chart, F series now becomes the best bang for your buck, if you will. You actually get the most compute power for the lowest cost. And so just so you can kind of see the side by side, this top line is what we had beforehand, and then the lower line is what we actually had prior. So you can easily see the vCPU cost versus the ACU costs. So B series is one of the really interesting ones because if you see on the top line, it's at the very top of the spectrum with only 13 cents, and then it moves down to the very highest price per ACU. So we'll dig into that right now, which is an interesting case. Oh, before we go on though, insider's note, we actually have a DV2 promo going on right now, meaning that so we wanted to offer our customers the benefit of the DV3, EV3 pricing. They're cheaper than the DV2s just because they're our new generation of hardware and we want people to move to them. However, we don't have the DV3 and EV3 in all regions. And so since we can't offer all customers who want to run in certain regions with these great prices, we're actually running this promo on the DV2 SKUs where you can get the DV2 sizes, but at the DV3 price. So you can go and resize your VMs to now have this lower cost for your virtual machine. And then it's easy to resize once we actually have DV3 in the region that you're looking for. All right. B series. So as you all know, we've launched a new burstable series. This is in preview right now. This is a very low-cost VM SKU, and the reason it is because it has flexible CPU usage. This just means that this is a really good SKU if you have basically a pretty idle machine that doesn't need the full CPU power, and at some point in time though, if you need to be able to burst, we'll actually give you that flexibility. So if you have a type of workload that's pretty low on the CPU utilization scale, then this could be an actually really great option for you. So for instance, small databases, dev test environments, web servers, things like that are really great. And how we actually do this is it's a credit-based system. And so once you actually go and deploy one of these B-series, we offer you a baseline CPU. And so basically, if you look at this top line, the B1S has a 10% baseline. So at any given day, you're going to run at 10%. And if you run below that, you actually build up these credits, kind of like a bank. And so as more credits come in, that gives you the opportunity to then burst and be able to actually go to the 100% of that vCPU. So we give you up to 100% times your vCPU. And so we go from 1 vCPU all the way up to 8. For region availability, we're not in all regions yet. We're working on it. But today we're in US West 2, East US, Europe West, and Southeast Asia. So just as an example too, what's really nice is in the portal, if you have one of these B-series that are running and you're not really sure how many credits you even have, do you even have the room to burst? You can easily go into the portal where you can see, here's how many credits I've consumed, here's how many remaining, which is really nice to be able to understand if you actually have the power to burst. And so as you can see, for me, I burst right around 8 o'clock. So, and then my credits went away. SQL Oracle Optimized SKUs. These are also a really cool offering that we just came out with that a lot of people I think are going to like if you run SQL and Oracle. What this actually is great for large database workloads if you have these, because what's nice about it is you save a lot on your licensing costs. And so I'll get more into this, but basically, what we're going to do is if you deploy a large size, we actually can restrict the amount of vCPUs we're going to give you to either a half or a quarter, but you're still going to get that same amount of storage, the same amount of memory, the same amount of IOPS that you really need to run these workloads. But if you don't need the full CPU power, then you can actually use these SKUs to save on your licensing cost. So for instance, if I have a G5, which is a 32 processor, I can actually enact the SQL Oracle Optimized SKUs by resizing to a G5-16. And this means that only 16 of the vCPUs are accessible to me. The full 32 are still allocated, but I only have 16 available to me, which means I only have to pay for a 16-core SQL license or Oracle license. That's kind of the half version. You can also do a fourth version. So if you only need the 8 CPUs, you only need an 8-core license. This is available today on DS, GS, MS, and ES. And then 2, this is not only for licensing that you have to purchase through Azure, but you can also even do this with your BYOL licensing that you bring from on-premise. So this is also a really nice aspect. And just to put it even in more details, this top line is basically what you pay for a normal G5, to where you'll basically spend $86,000 per year on the hardware costs, with $107,000 on the licensing cost. And so your total cost per year is $193,000. But if you apply the SQL Oracle Optimized SKU, you still get the memory, the disk, the throughput, but you get to save on that licensing cost. So your compute costs remain the same at $86,000, but your SQL Server cost has gone down by 75%, and you saved 42% overall. So this is a good one to use if you use these licenses. We've also just announced the Azure free tier, and so this is actually really cool. It allows customers to come in and use Azure for free for 12 months. And so what we'll actually allow you to do is you can sign up today, and we'll give you $200 of credit, and you can spend that however you want. And then afterwards, you can then opt in to the free tier, which will allow you to basically get a bunch of different products for free for 12 months. And so we won't ever charge your credit card until you choose to actually continue to opt. So here's a little website to give you more information if you're interested. And just to talk a little bit more about the compute perspective of this offering, what we're going to give you is 2 burstable VMs. So that B-series size that we had beforehand, that was the B1S SKU. We'll give you 2 of these, either Windows or Linux, your choice based on your workloads. And we'll also give you 2 premium storage managed disks with 64 gigabytes. And unlimited egress with 15 gigabytes of egress. So it's a pretty good deal if the burstable series works for you and you can run your web server or whatever you need to. And it's actually globally available except for our Germany and our Azure GovCloud. Two, I'm sure you've all heard that we've launched the Azure Reserved Instances. This is a really cool offering that allows you basically to purchase Azure at a major discount, around 70%, if you lock in for 1 to 3 years. And so it's super easy to purchase. You can basically select the VM size you want, select the region you want, select if you want 1 or 3 terms, and how many of these you want, and then you're done. You don't even have to specify if you want Windows or Linux. We can basically make the decision for you, based on whatever you deploy. However, if you do choose Windows, you will still be charged for the Windows extra licensing costs if you choose Windows Server. But what's really great about this is that if you join this with the Azure Hybrid benefit that Khalid will talk about a little bit later, you won't actually have that extra Windows cost associated. So you can still run Windows with an RI attached to it, and with this Azure Hybrid benefit, it saves you also on the Windows cost. So with this, just a couple more benefits. Of course, it gives you predictable pricing. So you pay one time up front for a locked-in price with a major discount, and that's all you really have to worry about for the next 1 to 3 years. 2, we have the capacity for you, and also, of course, the ease of purchase like we talked about. You only need the region, the VM size, and the quantity. Also, what's really cool is the assignment control. So if you're an EA customer, you don't have to apply these per subscription, but you can go all the way up to the enrollment number. So basically at your enrollment, you can purchase RIs that can then float down to your subscriptions. Also, if you ever want to cancel your subscription or your reservation, we do allow you to cancel, and there's basically a purchasing buyback that we're going to offer. And so there's more information on this, though, online that we can share. And here, I know that this screen is a little bit of a lot of detail, but it's because we give you a lot of detail in your bill. So if you actually purchase an RI, and this is still subject to change, but basically you're going to be able to see that bold highlighted inside that meter subcategory will actually tell you that this is a reservation meter. And then you see in the green, that's all that data, that metadata that's associated to your reservation. So you know the reservation number, what ID it's associated with, and you can even see what the other consumption meter you would have been charged. So that's really kind of nice. The second line item in this table for the Windows cost is basically telling you that this is a reserved instance that also has a Windows associated charge. So this is a charge for a 1-core machine, and this will actually have a price associated to it. However, like I mentioned, if you use the Azure Hybrid benefit, that way this is still a reserved instance running with Windows, but you're no longer going to have that secondary cost along with your Windows, because it's actually now you're applying your license, so you won't have that additional Windows cost. And you can see that it's Windows Hybrid benefit because of the image type. It actually says Windows Server BYOL. Also, along with planning, one of the best things you can do when you're planning how to save costs on Azure is actually tagging your resources when you first deploy or after deployment time. This will actually allow you to see who basically, you can tag it with anything. You can tag it with what cost center should this be applied to, what department, what owner, and 15 tags can be applied to any given resource. And if that resource is a billable resource, it will flow all the way down to your bill. So you'll actually be able to see that, and you can run analysis on top of it. What's really nice about tagging is we've initiated policies, and so we can actually enforce policies on either a subscription or a resource group. So for everyone who has access to a given resource group, you want to apply a certain policy, you can go and do that. And so just as an example, here's an example of a tag through the Azure portal. And so it's very easy to do. You can just go and save. And then once you save it, if you look at your usage details a few hours later, this tag will be there. And here's kind of the column where it's at. So these are the exact tags that I applied. 2, here's how you can actually set a policy. So basically, I have a policy on my resource group called group-8. And I want to make sure that everybody who has access to this group, if they ever deploy a resource within this group, it will have this cost center of R&D applied, so I know exactly who to cross-charge whenever I look at my bill later on. All right, so now that we've got through our planning section of how we actually can go about and make sure that we're doing the right things when we're getting started, next thing we're going to talk about is a little bit of automation. And so we have a lot of billing APIs that are really powerful if you use them. We have an invoice API that actually allows you to programmatically obtain your invoice. We have a usage API that you can programmatically get all of your usage details, and a rate card API that then basically all you have to do is apply your offer ID, your currency, and then you can easily go and find the prices for everything that we offer in Azure. So we also have a few of the EA-only APIs, which includes the price sheet, the marketplace store charges, and you can even see your billing periods and how much you've spent within a given time range. So just as an example, here's an example of the usage API. So all you have to do is basically, this is a REST API where you just have to input your subscription. You can then call the usage aggregate API with a given start date time and end date time. So for me, I chose the month of August. And you can even specify how you want to query. Do you want it to be on a daily grain? Do you want it to be on an hourly grain? So you have that flexibility to really get as much insights as you can. One example of a response is basically, you can actually see, this is just one given usage event within that given query call, where it basically tells you for this start date time, which was 8/31, I actually ran a standard B2 VM, and I even get all of this instance metadata, which tells me what actually was my ARM ID, what was my tags that I applied, and so it gives you that rich information that then you can do analysis off of. And one of the nice things too is that it returns the meter ID. So you can join this with the rate card API to then get automatic costing. So if you ever want to build any scripts to actually go and see exactly what you're going to be charged, if you want to build your own UI on top of that, we give you that opportunity with these APIs. And last but not least, of course, there's the quantity. So this VM ran for 8 hours. With that, I'm going to hand it back over to Khalid, who's going to talk a little bit more about automation.
So with that API, I can also audit what I've deployed, for example, and automatically writes scripts if I want to check if what I deployed is what I'm getting. Continuing on the automation theme, we want to also just show you there's a couple of features that you could take advantage of to make sure that you're not overrunning your infrastructure. These are some of the best practices. For example, the auto shutdown. It's been around for a little while, for a few months, so you can minimize on unused resources. So make sure when you boot up a VM, I think we've already switched the portal UI to be the default configuration. So when you boot up a VM, there is also already a check that will say auto shutdown, and you have to configure like a schedule to say auto shut, because most people may not be using the VM 24/7. We also have what we call auto scale. Auto shutdown is more kind of static based on a schedule. But if you're running like a large infrastructure, you can set up what we call auto scan, and I will demo these in a minute, to help you easily provision extra resources if you need them, or deprovision resources if you don't need them. And we'll talk about kind of some of the metrics you could use to, for example, tell whether you have a lot of capacity already or you need capacity to run your workload. Last but not least, I mentioned a little bit at the beginning on resize. You can resize a VM if it's not the right size. You can also resize disks, actually, as I mentioned, I think at the beginning for data disks, for example. So let's just quickly show you how these work in deployed infrastructure. So I'm going to switch to my demo machine and show you the. I have a VM here. Just quickly, we'll start with list of virtual machines. This is the portal I'm logging into in my own subscription. I have one of these VMs running. I can go directly to the portal. Like I said, it's a configuration that is already auto. It's a default configuration. So if you want to configure auto shutdown, you go to auto shutdown. It's there in the blade. And you can either enable it or disable it. In my case, I say I usually kind of don't need a VM post 5 p.m., so I set it up to my 5 p.m. Pacific time. I also can have a notification, so it will let me know. In fact, I believe when I get the notification, it will give you like a few minutes to want to continue. with the shutdown, or you might change your mind because you may still be working on that VM. I mean, I plan sometimes to leave at 5 p.m., but it doesn't always happen. So I may need another extra hour. So I can actually say, no, hold off. I know I set it to 5 p.m., but I can change it. And I do have, I think, a sample of auto shutdown email. I just removed my personal email from here. But basically, the way it looks like for this particular machine, it got the machine name. I can say postpone by 1 hour. 2 hours, or skip this instance altogether. So this is just a capability that is gonna, hopefully it's like a low-hanging fruit. If you don't mind, we'll do questions at the end with the microphone, just because, so we'll leave some time at the end for, I know a couple of folks raised their hand for a question, but we'll leave the questions at the end and we'll cover them. Then you can also set up a webhook if you want a service to actually take the notification and do something about it. I don't have one set up here, but you can set that up, and then you can set up the schedule as you wish. So that's the auto shutdown. You could do this at scale if you write a script, and you could do it through the Azure automation, but this is just giving you a flavor of it in a particular VM. Auto scale works really well if you have a group of VMs. So in my case, I deployed what we call VM scale set. Think about it, it's just a group of VMs that look alike. Instead of needing one VM, you may need 10 of them because your workload needs a lot of horsepower, a lot of capacity to run the workload. So I have one autoscale setup. I actually set up two. I was playing, one of them was giving me some hard time just before the session, so I ended up deploying another one, so I called it Auto 2. So this VM scale set has a very small one. It's like, it has 3 instances running. But the interesting thing about this autoscale this scale set is I've configured autoscale to tell it, hey, if my average CPU for all these 3 instances becomes over 50%, I want to start scaling down. And I put it 50% because I want to kind of demonstrate it in a fast pace. But in general, in a real life scenario, you may set that to be about 80%. I think 75 to 80% is probably a sweet spot for most workloads. You can also set up a policy to say, if it's below 30%, which is what I set up here, then I can start scaling up, scaling down. So if I look at the scaling option in the portal, so I went to the scale set, then I went to the scale in. This is what I define auto scale in the portal. You could do all of this through an ARM template as well and client tools. But in the portal, it's easier to kind of demonstrate it. So here I set it based on metric. I can set it based on specific instance count, or I can set it based on metric. In this case, I have one for scaling up and one for scaling down. So here, to scale down, once I start hitting 50% for my average CPU, I'm going to start, increasing my count by 1 because I need more resources to process because my CPUs are starting to become hot. Like I said, I picked 50%. It's probably not very hard. I could set it to 80%, but for demonstration purposes, because I want it to go quicker. Otherwise, it's hard to reach, a high number. I also want to set a policy when CPU is less than 30%. It means that the instances are not working hard enough, so you don't need a lot of them, so you can reduce that. So what I have here is I have this VMSS deployed. I can look at the average CPU, how it's going. So it's kind of been going up because I run this busy script. Just some automation I set up here in this endpoint. Basically, I just have a script that will do some work in the VM so I can simulate that the VMs are busy. So I can say, okay, well, I got 3 instances running now. Let me stop some work. So I'm going to reduce the load running on the VM. Okay, and then it will, the script will run. Hopefully, my connection is still stable. Yeah, so it's already starting, so it's kicked off. Now it's going to take time before this starts turning down. And that's what you will see is in the performance CPU, as it's going down, once it reaches the 30% threshold that I set up in my policy, then you will see the number of instances starting to go down. So you will see first instance will start getting into a deleted state, and then the second one. And in the policy, if you look what I showed earlier, I've got a min and a max. So I'm keeping my scale set as minimum 1 node, maximum 3. Now, obviously, you can set that to be like hundreds if you want, but for my particular case, I know, again, speaking of cost, I don't want to incur a lot of cost in my subscription, so I'm keeping it pretty low just for demonstration purposes. So that's auto scale. Last but not least is resize. So if you deployed a VM and then you find that it's mostly running at like 20% or less, or you might want to resize it. It probably has more horsepower than you actually need. So what you can do, you can easily go to that particular VM. So I'm going to go back to one of my existing VMs and go to the size option. So I go to the VM blade. Again, you can do all of this through PowerShell or favorite client tool, CLI. And then I can go to sizes or size. And then I can pick the size that is available in that particular region. So I can size up. I can pick, I had 1 core initially, so if I go back to the blade, you will see in my VM here, it's size A1, 1 CPU with 1. So I always use, just enough for me to, what I need. Now I can go and say, you know what, I may need more resources, I'll pick a bigger, I'm still gonna stay within A2, and that's it. And then I just say select, and then my resizing of the virtual machine will kick in. That's all I had to do. It will take probably a couple of minutes before it comes back up as it's doing, the updates. Sometimes you will see that the size you may be looking for does not exist for the region where you want to be deployed. So in that case, you may have to do some moving, to a size that is supporting that region. So the portal, I think by default, it will filter out the available regions for available sizes for that region, so you don't have to worry about it if you're doing it through the portal. But if you're doing it through a client tool, you can do a list resources for your subscription, and you can see the regions that are the SKUs that are available in the region, and then pick the size that you want. Okay, switching back to the slide deck. Those are just a couple of things to think about as you're managing your infrastructure. So we talked about auto shutdown, we talked about auto scale and resize. I know a couple of you have maybe a follow-up questions. We'll get to them at the end. So those are the demos. So now we're switching to bring your own license. So chances are you probably already have a bunch of licenses sitting if you're running your infrastructure on-prem. So it would be nice if you can bring those licenses to Azure and not have to pay extra cost for either the software or the OS. Well, we have some good news for you. We support bring your own license. We support pay as you go. So we provide you flexibility of paying on demand for software that you may not have, or if you have that software, you can bring it. For example, for Windows Server, if you have SA, software assurance, and you have licenses running on-prem that you want to use or reuse, you can go and recycle them, and we go into the details of this offer. This is called the Azure Hybrid benefits for Windows Server. This is something we launched recently. I will demonstrate it, and I will show you how it works in a little more detail. Also, if you have SQL license, SQL Server license mobility, you can bring those licenses into Azure. For this particular offer, it is currently restricted to only EA, so you have to have EA engagements or EA subscriptions. But if you do have the flexibility of bringing SQL licenses into Azure Virtual Machines, and we'll talk about some of the images that are available out of the box on Azure Portal and Marketplace. So Azure Hybrid benefits for Windows Server. This provides you ability to use on-premise Windows licenses, provided you have software assurance, and you can bring those licenses and save a lot of money. Basically, you don't have to pay for Windows license on Azure on demand. The way it works, there are some rules that you need to be aware of. And the first is Azure Hybrid Benefit is applicable to Windows Server Standard and Data Center. So if you have licenses for Standard or Data Center, you can reuse them and recycle them on Azure. Data centers with some rules, data center benefits allow for simultaneous usage of the license. So you can be having that license being used on-prem and on Azure simultaneously. However, if you do have Standard Edition license, it can only be used one or the other. So those are just some of the rules you need to be aware of. There is a 90-day rule if you go through the licensing details, but that rule does not apply for Azure within Azure Virtual Machines. But if you are moving a license to Azure, you cannot bring it back until 90 days. But if you are on Azure and you're running on a particular virtual machine, like I showed in the auto scale, virtual machines are basically just kind of a bunch of cattle resources. You can just recycle that license and use it in another virtual machine within Azure. But if you are moving the license across Azure and on-prem, you need to be aware of the 90-day rule. This is just an example, each 2-processor license or each set of 16-core licenses entitle you to either 2 instances for up to 8 cores, or vCPUs, or 1 instance of up to 16 vCPUs. VMs with more than 16 cores or vCPUs can stack licenses. And we'll go to some examples so it's kind of more clearer. So I'm going to take like 4 examples just to give you an idea on how you can kind of use these licenses. The first example I have here is you've got 1 VM, you get 1 PROC or 16 cores license. In example 1, you are using 1 VM with 16 CPUs, and this will be a D16 V3, which has 16 vCPUs. Okay, so in this case, you're maxing on the number of CPUs because the maximum is 16. In the second example, you're maxing on both CPUs and VMs because you're using it to the most, which is 2 VMs, and each VM is 8 vCPUs. So that adds up to 2 maximum VMs and 2 16. Straightforward. Second one, I'm using 2 VMs max, but I'm not using the licenses efficiently because each VM is only, 1 VM is 2 vCPUs, another VM is 4 vCPUs. If I add them up, basically I'm using 6 vCPUs, but I'm maxing on the 2 VMs. So I've used 1 license, but only with 6 vCPUs. Not very efficient, but we allow you to do that, but it's not very efficient because you're losing on the number of vCPUs you could have used. You can stack up licenses. In this example, I've got 2 PROC or 32 core licenses. So in the example 4, I've got 1 VM D32. It's got 32 vCPUs. So because maximum was 16 for 1 license, I can use 2 licenses and use this larger VM. And the last example, it's not something that lines up very well, but you could still use it. So with a GPU NC24, it's got 24 vCPUs. So 1 license allows me up to 16. So I have to use another one. But the other one will take me up to 24, but I'm losing, if you will, on the number of vCPUs because technically I could use it with a bigger VM. Okay? So just some examples on how you can stack up licenses, how you can use the Azure hybrid benefits in Azure. This is the calculator. It's available. It's live. You can go and plug in some numbers. It will help you. When you pick, it will tell you how much the cost would be, and you can compare it to without using your license, and then based on that, you can save a lot of money, and you will see as we drill into that hypothetical scenario, how much the cost is. It could actually be 40% and sometimes more, depending on, like I said, the skill. As you saw, just in these couple of slides, there's like 4 or 5 examples that we can go through. One question that come up is where can I see the hybrid use benefit? Megan actually showed it in part of RI, kind of similar. So if I'm only using this outside of RI, if you look at the bill under additional info, you'll see the Windows Server BIOL. That's just the old name we have. Maybe we should rename that. But it is, that's how you know that you are running with Azure hybrid benefits. Can Azure Hybrid Benefits use for classic VMs? The classic VMs, we're not adding a lot of features. This is a newer feature. However, if you build your own custom image and you want to recycle your licenses, by all means, you can do that. However, you cannot deploy gallery images like Windows Server from the gallery or marketplace and use the hybrid benefits. It's only for the ARM-based model, but not the classic VMs. So to use the feature, you can migrate. And there is a nice session about migration of Classic to ARM that you should attend. I think I have it in one of the reference slides. You can go through that session and do the migration, and then you can take advantage of this. So let's actually take a look how it looks like. So I'm going to switch quickly on my demo machine just to give you an idea how the hybrid use benefits looks like. So what I have is that same VM I was showing you earlier. It's actually a VM. So first, let me try to deploy one. So when you go through the port experience, should be straightforward. You go new, plus new, and then you go to computes, and then you pick any of your favorite Windows Server machines. I'm picking the top one here. I've got a 2016. Then what you will see in the experience here on the bottom, you can say save up to 40%. You can say yes, and then it will ask you, do you confirm that you have a license? Make sure you have a license, obviously, to use it. And then that's all it takes. And then you just go through the deployment, just like deploying any other VM. What happens behind the scenes, we'll know that you're asking for hub and using your license, and we will, deploy it for the hub use benefits behind the scenes, and then the billing behind the scenes will not charge you for additional cost for the VM. And then in your bill, you will see that, constructs that I showed earlier. You may be wondering, okay, if I deploy the VM, can I query it from the control plane? By all means, yes, you can. So what I'll show you here is that same VM that I deployed. If I just do get on the VM, see what this is. Oh, minimize this. So if I zoom in, so what you'll see here in the construct is license type equals Windows Server. That's how you know it's been deployed, and then if you check your bill, that same VM should be charging that cost. Another thing you can do, let's say you've got a lot of VMs deployed in your subscription, and you want to see which ones are using the licenses and which one not, because chances are if you're running a large infrastructure, you want to know, and you want to cross-check if licenses that you're using on-prem and so on. So you could run, I have a quick query here, you could list all the VMs in your particular subscription. You could just run like an example loop like I have here, and it will, in my case, I've got 3 VMs. 2 of them are using the hybrid use benefits, and they have 1 without. Okay, so that's kind of how you can just do a quick listing of the infrastructure. Another thing I want to show you quickly is I mentioned about SQL mobility, SQL Server mobility. There are a few SQL Server images that come with the support for using your existing SQL licenses. You could feel free to use any of these. These are already prepackaged to be and optimized for EA to be used if you have existing licenses. You could just go ahead and deploy it, but just know that you need to have an EA subscription to be able to deploy them. So the experience of deploying or using your existing SQL licenses is just the same as deploying on demand, really. The only difference is when you look at the bill, you'll be paying a lot less. Just quickly, to broaden this pay-as-you-go, so you may be using other solutions besides Windows Server license and besides SQL Server. You may be using other third-party marketplace. Azure Marketplace has hundreds, if not actually a couple of thousands of solutions now that you can go and deploy. And chances that you may be running some of these third-party ISV solutions already on your own premises, and you want to continue to use them on Azure. By all means, you can go to Marketplace, search it. I just did a quick search, for example, for a Barracuda email security gateway. I can go through it, go to my to the existing pricing page, and what you will see, you will see the BIOL option, or you'll see pay-as-you-go option. And then it will tell you here in more details how much you're going to pay if you go with BIOL, so with BIOL versus pay-as-you-go. So as you can see here, for BIOL, I don't have to pay extra cost because I have a license. And then you just make sure you pick the right solution for BIOL. Then the ISV is not going to charge, or Microsoft is not going to charge you any extra cost for that. If you don't have a license but you want to continue to use it, obviously you can pay as you go, and you'll see the prices on the pricing page. Okay. All right, I think let's quickly the demo, switching back. Thank you. And let's see if, what's next. Oh, so now that we went through the BIOL, just by looking at those numbers, if I went and used all my, assuming I have these licenses sitting in my on-prem, that I've got these 10 web application VMs, I could drop from $75,000 that I had there to about $39,000, and I can drop the rest. If I have SQL, happens that I have both SQL and Windows. This is hypothetical. It's possible you may have these licenses. It's possible you may not. But if you do, you get that option. And then if you do the math, it will turn out to be about 46% savings just by using my existing licenses on-prem, which could end up being a lot of money, thinking from $600,000 down to about $300,000 give and take. If I become even more efficient with my infrastructure by using the auto shutdown. And what I did here in this particular scenario, I said, look, I may not need all these web applications running 24/7 every day, the whole year. Chances are, potentially, I could go buy 5 running VMs for my web application VMs, and then the other 5 can run only 12 hours a day. I don't need them 24 hours a day. So I did that, and then I did the same thing for the worker roles. I said, okay, I'm just gonna run at 50%, 12 hours a day, okay? And then 100%, 24 hours a day. So even with that, which is not very unreasonable, and then I did the same thing with SQL, and for all my VMs, and I kept all the data running 24/7. I'm not gonna do any cleanup of data and everything. Even with that, I was able to drop it by, but 54% savings. So the price drops almost to $273,000 for this particular hypothetical example. So just gonna give you an idea of how much you can actually save by just doing some tweaks here and there. And then if you do not automate some of this, the prices can rack up very quickly, so you need to make sure you, again, as part of the planning we discussed earlier, to account for these. Okay. Now, let's switch to monitoring. I think I'm going to hand off again to Megan, and she'll walk us through some of the aspects of how you can monitor your infrastructure.
Awesome. Thanks, Khalid. So monitoring, of course, is very important. As you all know and have heard inside of a lot of the keynotes, that we now have Cloud-In for free for all customers, which is really great. We also offer other things like spending limits. And so if you have fault-tolerant workloads that you can apply a spending limit onto, that will automatically shut down your workloads, you can do so. That is restricted to a couple of different offer types, though. You can also apply billing alerts, meaning that, for instance, if you want an alert to say, I want to know when I've spent half of my monetary credits, that can also go out. So we'll demo a couple of these. The Azure Advisor is also really great, and it's integrated in the portal, where that can tell you some cost optimizations that you can provide. And 2, of course, we'll walk through the Cloud-In portal. So I'm going to come over to my demo machine here and switch over. So here is the billing accounts portal. And so what I'm actually going to show you is how you can actually set an alert for your billing. So here I'm just at I've got a Visual Studio MSDN account. I can come over here and easily click alerts. And this should load. But if it doesn't, we can come over here. So if this page would load, here's what you'll basically see, where you can type in an alert name. So if I want to just say Megan's alert, and then I can come through and I can basically say, I want to know, for instance, when my billing total or monetary credits, let's say I want to know when my monetary credits is at $75. That's half my account, since I have 150 free monetary credits. I can then send an email to myself and just click save. This will save an alert. You will then get basically an email that says your alert is now enabled. And if you actually ever hit $75, it will send you another email saying, by the way, you've hit your spending limit. Maybe you should go take a look at your account. So that's one of the offerings. 2, we actually have integrated in here the cost management with Cloud-In. And so if I come over here, I can actually click on cost management, which will take me to the Cloud-In site, where you can then easily integrate to the Cloud-In web portal. So this will take me to Cloud-In site, where it will you'll get a lot of different benefits from here. So this will actually tell me that I'm spending $11,000 over the last day, which is quite a bit. And I have 714 unused RIs, and with 3,500 instances. So this is obviously a lot of data. A lot of different subscriptions are integrated into this account. So if I want to, I can actually come over to Cost Controller, where I can actually see, here's my monthly spend, here's my cost over time, and if I keep going with how I'm going, I'm going to eventually spend $3.5 million within the next 12 months, which is a very high amount that I cannot afford. So I need to figure out how I can actually optimize this and get better. So we have the optimizer here. which you can click over, and it basically tells me, I have 32 recommendations to apply RIs where RIs aren't applied, so I can go and actually set those. 2, I can actually look at sizing recommendations, so I should actually resize, it looks like 101 of my instances where I can save a bunch of costs. And so this is really nice to be able to drill into and understand how you can actually make your organization way more cost effective. And with that, this is actually free for all Azure customers. It's integrated into the portal today, so I really highly suggest checking it out. With that, I'm going to switch back over and invite Rick up to talk about how Cloudera estimates costs whenever deploying a Cloudera cluster. Thank you.
Thanks.
There we go. And we can, yeah, perfect.
Yep. So thanks, guys, for inviting me to talk. I'm going to walk through, hopefully, a quick example, because I know I'm between everyone in Q&A and the rest of the evening. So I am going to simplify some things, but I'm still going to try to go through a real-world example of going from a workload and expanding it out to show what it takes to actually run that workload in Azure. So we're going to go through planning and costing a Cloudera cluster in Azure. We'll talk about sizing the cluster, what that exercise looks like. That'll involve workload analysis, looking at the cluster resource requirements, and then we'll break it out into a service matrix to show the breakdown of the things that actually end up running, and we'll talk through some additional considerations. So I do have a note in here. We're not going to have time to cover a lot of facets here, such as instance size selection, comparisons between premium disks and standard disks, and Azure Data Lake Store as storage options. And I'm also going to skip over doing network-constrained workload analysis. So sizing a cluster in Azure. So if folks aren't familiar, Cloudera sets up Hadoop clusters, and we have the ability to do this on-premises and in the cloud. A Hadoop cluster is basically a large collection of machines that can do work for you. They can be 10 nodes, 100 nodes, sometimes even bigger. So the sizing exercise is very similar to what we would do for on-premises, except that mistakes are a lot easier to fix. The main considerations that we have to look at are the workload, the concurrent use, the size of data, and the SLAs that you're trying to meet with your compute. So for this planning exercise, we're going to use a reference workload. It's a little bit contrived, but it's a well-known reference workload called Terasort, over 5 terabytes of data. And what Terasort does is it basically just takes a large swath of random numbers and then sorts them and puts them in order, and it spreads work across the entire cluster. So it's a well-known workload that we can use to size the cluster. The input is low churn, so we do have changing workloads, so we're going to have to resort things after a while. We're going to use HDFS snapshots to keep the data consistent for the sort input so that things aren't changing as you're sorting, and that's going to require roughly 10% more space to keep that version for processing. And the business constraint we're working with is a 1-hour SLA. So we want these batch jobs that are doing the sorting to complete in 1 hour or less. So with that workload, we go in and we do some analysis. And this is where I start doing the thing you're not supposed to do in PowerPoint slides. I've got a bunch of math up here. And this isn't to scare anybody that you have to do math to do sizing. It's just to remind folks that these are known quantities. So you can look at how much data can be brought into a VM, how much data can be processed by the CPUs and so forth. So you can take some known quantities about the workload and back it out to the resources that you need. So the inputs, we've got 2 data sets, 5 terabytes each, 110% to account for that 10% data churn every hour. HDFS replication in the Hadoop distributed file system, we keep 3 copies for availability and durability of the data. And then we've got a 1x overhead, and that's just a rough swag that we generally use about 25% of our disks for overhead and spill. The outputs, we're going to keep 2 sets of data around, so we have 1 data set that's available for end users and 1 that we're currently working on. And multiplying all that out, we get 44 terabytes for the inputs and 80 terabytes for the outputs. And so our total storage requirement's 124 terabytes. The next thing that we look at is the sort throughput. I know from historical testing that using the VM sizes that I selected, that I can sort a certain amount of data per VM, and we need to sort 5 terabytes of data for 2 data sets, and that comes out to roughly 2,800 megabytes per second of sorting that this cluster needs to be able to do. We also have to look at the premium storage I/O capacity. So we have to be able to get the data out of storage up into the VMs so that the sorting work can be done, and then we have to write that data back out again. And you can see that I've done the math here, but we're basically looking at 5 terabytes times 2 to read, and then 5 terabytes times 2 times 3 for the replication, and we're adding in that 10%. And what it ends up looking like is about 12,000 megabytes per second that we need to be able to write out across the cluster. So it's not one VM that needs to do this, it's that the entire system needs to be able to do this. Network sometimes is very relevant. It's not particularly relevant for this workload, and it is complicated to analyze and figure it out. But we're discounting that one for today. So taking that workload analysis, we're going to look at what we need the cluster to actually be able to do from a sizing perspective. I said we are picking the DS15 V2s and P30 premium data disks that are 1 terabyte each. So we just take this one resource at a time. The disk resources. We know we need to store 124 terabytes of data. Cloudera documentation recommends that for these DS15 V2s that you have between 5 and 20 P30 disks. That's a more constrained range than is possible to attach to these from an Azure perspective, but that's where we've seen the best performance and reliability. So that means that if we were just constraining things on data, we would need a minimum of 7 nodes, so that's 124 terabytes divided by 20 terabytes each. So that's a 7-node minimum for disk. Looking at the next possible constraint, we're looking at compute resources. So I said that I had, from historical testing I've seen with this size data set, this DS15 V2, can sort roughly 100 megabytes per second per node. So looking at that need for 2,778 megabytes per second of sort, that means that we need about 28 nodes if this is a CPU constrained workload. And the last one is the storage bandwidth. Premium storage I/O capacity. We need that roughly 12,000 megabytes per second of I/O capacity. The DS15 V2s are documented for uncached premium storage throughput at 960 megabytes per second. So I did a conservative estimate of actually getting 900 megabytes per second out of each node, and that would give a minimum of 14 nodes. So since the one in the middle was the largest number of nodes, that's the constraint. That's where we need to define our cluster size. And that's the one that's highlighted in the middle. And just a quick note, because we need 28 nodes, we don't need to load them all up with the top end capacity on storage. So you can actually size it back down. Instead of 20 premium disks per node, you only use 5 premium disks per node, and multiplying that out by the 28 gives you the storage that you need. So this is a bit of an eye chart, but it shows how we break things up per the different types of nodes that we use in a Cloudera cluster. All the pricing is by month, and these are East US 2 pricing that I got last week as we were pulling together this presentation. A few things to point out, and I think you guys showed this as well. You need to count that OS disk. It's not very expensive, but when you're looking at a large number of nodes, it can start looking like a big error in your bill compared to what you're predicting. Cloudera recommends a dedicated log disk so that we're never blocking performance on the data disks based on logging. So each of our nodes there has a dedicated log disk. And then the worker nodes, the ones that do the bulk of the work in a Hadoop cluster, are the ones that have those 5 P30 data disks to give us that bulk storage capacity that we needed. So this is how those things all add up. You've taken that workload that you know what you need the capacity of the VMs to be able to do, backed it out to the actual resources that are needed, and then sized that out to be the cluster to do the work that you define. A couple of additional considerations. You guys mentioned pulling data out of Azure, coming out of the zone, can cost real money. If you took this example workload and downloaded the data every week, you end up with some extra thousands of dollars on your bill. We like to plan for for resiliency. So if there is diminished capacity, if you have an outage in Azure, do you want your workload to be able to go through that outage? So we typically recommend deploying into 3 fault domains in an availability set. If you lose one of those fault domains, do you want your cluster to be able to meet the SLAs through that? If so, you got to size your cluster up by 3/2. The last point is, in the cloud, it's easy to add resources. So in the past, when you're like having to create a PO and order hardware and wait months and months before you can start your project, a lot of times we would add 50% or sometimes 100% just in case, because we didn't want to be the ones that planned the size of the cluster and then it shows up and it can't actually miss the business needs. Now you can actually cut that a lot closer because it's easier to fix the mistake. So you can give it your best guess and give it a marginal, a bit of additional capacity, and then deploy it and run it and monitor it. You guys showed the monitoring. When a cluster is running at peak efficiency in a Hadoop cluster, we are going to be hammering the data nodes. Some resource on the data nodes is going to be very busy. So if even if Azure shows those worker nodes very busy, the cluster still might be in a healthy state. But if that peak usage that's showing up in Azure monitoring is also showing your SLAs creeping up, then it may be time to add nodes. Similarly, if the monitoring is showing unbusy resources, or if your SLAs, even if your resources are busy, if your SLAs, you want it to be an hour and it's completed in 30 minutes, you may be able to remove some nodes. So hopefully that gives a kind of a concrete example of how we take a workload definition and back it out to a cluster in Azure.
Thank you, Rick. Thank you. All right, so I think we're just about time, but I want to just quickly recap, and I want to get to, because I promised to take a couple of questions. Just to recap, avoid surprises, plan, pay for what you use, no more. You don't need to pay extra if you don't have to. Automate to ensure resources are used efficiently, using your existing licenses, obviously, and then continue to monitor resources. And just some related sessions, some of them already passed, but they are recorded. So go ahead and get more information about some of the topics we didn't drill into. We were more focusing on the cost aspects, but there is a few great sessions. If you have missed them, you can still watch them. And there is one still coming up from Guy and Kay tomorrow in the afternoon. And then maybe we'll take a couple of questions. However, we're going to be in the booth, in the Azure Compute booth. So if you have more questions, don't feel like you have to ask now. We will be there. We'll be available to answer more. But we'll take a couple of questions. I think somebody raised their hand. Please come to the microphone so everybody else can hear you, and then we'll go from there.
2 questions. Number 1. Why is there an auto shutdown without an auto start?
Without auto starts?
Yeah.
How do you start them back up?
Good question. So you're looking for like an automatically after it's done.
I know it's in dev. It's been in dev forever.
Yeah.
Why isn't it in production?
Yeah, good point. I think we should look at maybe an auto start or allowing you to do it automatically once it's done.
What do you tell people to do who want to use the auto shutdown feature along with an auto start? Do they have to use a runbook or what?
Yeah, you can automatically restart it after, based on particular time of the day or schedule. Go ahead. Yeah.
So.
Yeah. Portal. Yeah. Portal does not.
Okay. So the next question was, all of my Azure objects are in US West 1.
US West.
West. And US West 2 is cheaper. So how do I move all of my objects from one zone to another?
And these are all virtual machines already deployed in production?
Storage, network, everything. How do I move everything I have from one zone to another? Because it's cheaper.
Yeah, let's talk some more. I think that question will require some more drilling. There is some options we can dig into depending on the specific for your deployments. Anybody else?
One question,
Yes.
or maybe a suggestion. So in the create VM process, when you get to the end, you can run the auto shutdown, it asks you for a notification. Do you want to be notified prior to? And then you can plug an email address in there.
Yes.
You don't have the option to add the webhook. You have to you can put the email address, partially complete that process, but then you have to wait for the VM to be provisioned and complete, then go back over to the VM, go to the auto shutdown, and add the webhook entry there. It's like halfway complete. You're only getting one piece of that.
So you couldn't set the webhook when you set it up? Because when I showed earlier, there is an option for webhook. What you're saying is during the initial deployment.
During the initial creation of the VM, you only have the option for the email address, but not for the webhook.
I see.
You have to go back afterwards and add
Got
the
it.
webhook.
Got it. It's a good point. I need to look into it, some more, but I need to find out more about that particular scenario. But you could set it afterwards, but you're right, it's probably not very convenient.
Yeah.
Question on the billing alerts. In the billing portal, is there a way to set billing alerts per each resource group rather than the whole account?
So right now, it's just in preview per the account. I'll check with the billing portal team though to see if there's actually work being done to do per resource level grouping. I think that's a good idea, but I'll definitely check on it. Right now, I think it's just in preview though for the sub.
Yeah. And then the REST APIs that you showed, where can I find them?
There's public documentation, so if you just search for just Azure Billing APIs, it will pop up. We've got a documentation page on it, and I can also share a link.
Let's take one more question here. I think we are a couple of minutes over, but we'll take one more. For anybody else who wants to ask a question, please, we will be in the booth. Feel free to stop by.
Yeah, just two quick questions. The first one, the Azure hybrid use benefit. When are you going to allow people to flip existing VMs to use the Azure hybrid use benefit?
That is, let's talk, if you could stick.
Okay.
That is coming up soon.
Okay.
That's something we're working on.
Okay, and the last thing is the reserved instance. When's the ETA for that to go GA? And then also, is it a prepay purchase program? And then how do you prepay for it?
Yeah.
Yes, it is a prepay, so you pay on whenever you purchase it for the whole thing up front.
Okay.
And then end of calendar year for GA.
So you can prepay for it for pay-as-you-go, CSP, and EA customers? Oh, see, okay, a little bit later. Okay, all right.
Yeah, if you want to stick for the first question, I can try to help you. I have some options. Thank you, everybody.
Thank you.
Appreciate it. Thank you very much. Have a good afternoon.